Welcome to Algebra 1, Unit 6, Lesson 6.6, Parallel and Perpendicular Lines, Part 3. Pearson Algebra 1, copyright 2009. Objectives. I will be able to find the equation of a line parallel to a given line, and I will be able to write the equation of a line perpendicular to a given line. In this lesson, keywords again, slope, recurring theme. Slope is given by the variable m in most of what we're going to do today. The negative reciprocal applies to perpendicular lines. So negative reciprocal and perpendicular lines, they're connected because the slopes of perpendicular lines are negative reciprocals. Our point slope form, I'm not really going to be talking about that in this lesson. In this lesson, it's going to be working with the slope intercept form. Parallel lines have the same slopes, so that's something to remember. As we move into example 4T, real world problem solving. The line in the graph represents the street in front of a new house. The point is the front door. The sidewalk from the front door will be a perpendicular to the street. Write an equation representing the sidewalk. So the sidewalk from the front door will be perpendicular to the street. Write an equation representing the sidewalk. So what we want to solve for, what we want to have for our answer, our final answer here, we want to have an equation. We want to have an equation representing the sidewalk. How are we going to do that? Well, we have to look at and find the equation. We have to find important information about the equation of the street. And basically what we need to find is we need to find the slope of the street. We need to find the slope of the street because we know the line that we're going to find is perpendicular to it. So first we need to find the equation for the sidewalk, we need to find the slope of the street. I guess I shouldn't really put a 1 there. What we want to do is write an equation for the sidewalk. That's what we want to do. So to do that, our first step is we're going to find the slope of the street. We have to find the slope of the street. So the slope of the street, if we just use identifying what are called good points, to go from this good point to this good point, we have to go down 2, which is represented by a -2, and we have to go to the right 3, which would be a +3. So the slope of the street, or the line representing the street, is a -2/3. Now, because we're finding the equation of the line perpendicular to that line, we want to use the negative reciprocal. There's that key word. We want to use the negative reciprocal. So we want to find the negative reciprocal of that line. We want to find the negative reciprocal of that. So the slope we're going to use in this case is the negative reciprocal. The negative of a negative is a positive, and the reciprocal of 2/3 is a 3/2. So the slope we're going to use is 3/2. Now we're going to use point slope. Now actually we don't have to use point slope because this equation here, or this point right here for the front door, is the y-intercept, where x is equal to 0, 0, 4. So we can go straight to slope intercept. So our third step here is to use slope intercept. So we're going to use slope intercept, which remembers y is equal to mx plus b. We'll substitute m in for this slope, which is 3/2, not 3/3, 3/2. X. And the y-intercept, we know from the graph, is 4. So it would be +4. Actually, be a -4. I mismarked that. Actually, be a -3, not 4. I misread that altogether. It'd be a -4 or -3. It'd be a -3. That's down 3. 1, 2, 3. So that would actually be a -3 right here. So this is the equation for the sidewalk. -3, and that'd be the y-intercept, and this would be the slope, 3/2. So from here we go up 1, 2, 3 over 2, and hey, there'd be the sidewalk going out to the street, just like that. So this equation is the line perpendicular to the street. This has been Mr. Pilarski with parallel and perpendicular lines. Thanks for watching. Bye-bye.